Hey, it's Mr. Wine here. Last week we talked about speed, and specifically we did some claims and evidence around how we claimed that something was faster or slower. So a lot of you were saying things like, I know that I went faster when I ran because my time was less. So we know there's a connection between time and speed. I'm going to show you an example of a race between some fast running humans and some fast running animals and some vehicles, all to kind of see, can we tell how fast something is by time. So in this example, we'll see that everything is running 100 meters, and as the race starts, things take off. So the fastest land animal of a cheetah finishes the 100 meters in just 3 seconds, where things like a lion is 4.7 seconds and the human finishes in 8.2 seconds. Okay, so yes, we can use time to be a measurement for our speed, but in that case, all the distances were the same. What happens if the distance changes? What happens if the time changes? How do we really use these two measurements to determine speed? Okay, on this graph, we see on the y-axis something that says distance from starting line. And on the x-axis, we see time in seconds, and this was in meters. So meters, we remember from last week, meters was a word that measured distance. So that's a distance unit. And time was a measure, seconds was a unit that we used to measure time. And I've got a little stopwatch here on the bottom that's going to show me my time. And on the bottom here, I also have a little red person who's going to run. And there's a 10, 20, 30, and 40 meter mark. Just like on the graph, we see 10, 20, 30, and 40. Okay? So we're seeing there's a relationship between distance and time. So as we said before, our distance goes up to 40, and this shows a time can go up to 4. What happens if we go all the way up to 40 and all the way up to 4 on our graph? Let's take a look at what happens with the runner. The runner is moving, and they go all the way to the 40, and they end exactly at 4 seconds. So let's go back to the beginning now. And now let's change our distance. What if in 4 seconds the person only runs, or the person runs just 20 meters? What's that going to mean for us? Let me move this over here. Okay, so now we're going to push play and see what happens when the runner goes just 20 meters in 4 seconds. Okay. Did you say that it was going to be faster or slower or the same? I hope that you said it was slower, because as we can see from that graph, the red person went much slower. Okay, I'm going to go back up again. To show you that, I'm going to add runner 2. What do you notice about the blue runner on the graph as you do the red runner? Is the blue runner steeper, less steep, about the same? What are your thoughts? Is the blue runner going to be faster or the red runner going to be faster? And how do you know? Ready, go. As we can see on the bottom, the red runner moves much faster than the blue runner, and they finish the entire race in the same 4 seconds, whereas the blue runner only gets about halfway. Okay. We can also see what happens. I'm going to take the blue runner out of the equation again. The graph. Maybe this time the red runner does something like this. What do you think is going to happen in the middle section between these two dots? If I push play, what's going to happen in that part of the graph? Here we go. Let's see. As that part was flat, we saw that there was no motion. The person just stopped at the 20 mark and didn't move until the graph started going up again. So the steepness of that graph is telling us their speed. Let's bring back in runner 2 now. And this time runner 2 is going to keep a straight line. Okay, so runner 2 is on a straight line, and runner 3 is going to do this kind of zigzaggy line. What do we think is going to happen there? Go. So runner 2 stops, or the red runner stops, but they finish at the same time. The reason they were able to finish at the same time was because of what? How do we tell the difference between this red line here and the blue line here? The blue line here and the red line here. How are they different? What is telling us that they're going faster at that time? Okay, so in summary, we want to talk about the fact that the way when we change the graph by its steepness, oops, that's not what I want to do. So as we make the graph steeper, we're seeing more distance in the same amount. So now, in this, I go the same distance of 40 meters in less amount of time. So now I'm going 40 meters, but I'm doing it in 2 seconds. What does that mean about the speed of this person? Let's see. So they moved really fast. They went super, super fast. Let's bring back in the blue runner. And this time we're going to have the blue runner just do the normal straight line. And let's see what happens here. Which runner will be faster, the red or the blue? So that at the end, they're both in the same spot, but the red runner got there much quicker. Okay, they did it much more and much faster, meaning that they did it in less time to go the same distance. So what we see is if you go the same distance in less time, that's going to increase the speed. If I go a farther distance, or if I go less distance in a same amount of time, I'm going to be moving slower. Okay, and if on a distance time graph we don't see a change, that means that time's going by, but they're not moving.